Good afternoon to your grade 10 Mindsetters. Welcome to it. This is your favorite learning show, the best show ever, Learn Extra Live, with me, AB, on a Monday, which we call a Triple M day, the Mindsetters Met Monday. I hope you had a great day at school and your weekend was fabulous, just like mine. Otherwise, we're here to learn more, and we are with Natasha. How are you, Natasha?
Hi, I'm good, Abraham. How are you?
I'm feeling good. It's been a great weekend. A lot of things were happening over the weekend. From Friday, Valentine's Day, Mindsetters have been enjoying themselves. Even at school, they had some programs. So it's been busy on the page. But otherwise, I hope you're good too.
Yes, I'm very good. Always good to be here on a Monday. And I prefer to call it Manic Monday rather than Triple M Monday.
May I ask why?
Well, no, let's not get into it.
All right. It's cool. Since you're wearing a red t-shirt today, still in the month of love, what are we doing today?
All right, guys. So today we're looking at exponents. It is really... I say this about every section, but it is a very important section because you will build on all the knowledge that you get from today's lesson, and you'll keep it with you until you get to grade 12.
Awesome. Let me tell the Mindsetters what they need to do. Firstly, you must join us for this show by also going to facebook.com/learnextra. Like the page, also share the page with all your friends, your classmates, your roommates, everybody else that is around you, and say, let's learn more on Facebook. But also, you can tweet us at learnextra. Follow us. I'll read some of your tweets later on. And lastly, download your notes all for free at learn.mindset.co.za. But otherwise, downloading your notes will also put you through to an awesome opportunity whereby you get to answer our test yourself questions and fill in an entry form, which is on the link that I'll post on Facebook. What you do on that form, it is a Google form. What you do, you post in your answers there, and you stand a chance of your name being through to a draw whereby you could win an airtime, proudly sponsored by Vodacom. Winners of this show will be announced tomorrow. So here's an awesome opportunity for the Mindsetters. All they need to do is to test themselves.
Absolutely, and I think those questions were designed to get you thinking, but also not to be incredibly difficult. So if you know your work, there's no reason why you can't get all the answers.
Know your work and get the right answers, and then stand a chance of winning an airtime, proudly sponsored by Vodacom. But we also have a challenge question, of which Natasha will tell us more about it.
Yes. All right, guys, so in today's lesson, as I said, we're going to be having a look at exponents, and we're going to use all the laws of exponents in order to help us simplify exponential expressions and then later on exponential equations. Our challenge question for today looks like this. You have to simplify x to the power of -1 minus y to the power of -1 divided by x to the power of -1 times y minus y to the power of -1 times x. Guys, the only clue I'm going to give you here is that, remember, when you're dealing with negative powers, it implies division. Okay, so negative powers straight away tells you that something is going to be divided by something else. All right, so if we're looking at negative powers, we're talking about division. All right, and we'll get more into that as we go on with the lesson. But first, the first thing I want to do is just remind you guys about your exponent laws before we actually start the application of that. Okay, so let's start with our first one. So these are your exponent laws. It's really just brushing up. So the first law says when you multiply exponents with the same base, so as you can see here, our bases x and x are exactly the same. When you multiply exponents with the same base, you add the powers. All right, so I've got x to the power of m times x to the power of n. Because the bases are the same, I keep the x and I add the powers. All right, something most of you will already be familiar with. The next law says when we divide exponents with the same base, we subtract the powers. All right, so my same base here again is x, and my powers I'm simply going to subtract because I am dividing x to the power m divided by x to the power n. So I keep the x and I subtract the powers m from n. Okay, I'm going to skip over laws 3 and 4 and go down to 5 and then come back to 3 and 4. So, if you look at number 5, it says, when we raise a power to a power, we multiply the powers. So I kept my base and I multiplied the m by the n. So x to the power m raised, when we see the bracket like here, we don't say times, we say raised to the power of n. That's going to be equal to x to the power of m times n. Okay, now the reason I want to go back to number 3 and 4, it's really just an application of that law, raising a power to a power. If you look within this bracket, we now have two different letters. We've got x and we've got y. Remember, whenever there's no power, there's always an invisible 1. When you're dealing with two terms inside a bracket, not really terms, two factors inside a bracket, you're going to raise each one to the power outside the bracket. All right? So I take the x to the power of 1, I times 1 by m, and I will get x to the power of m. And then I take the y, which also has a power of 1, I times 1 by m, and I get y to the power of m. Guys, please, this is a common mistake, is people will often do this and say it's xy to the m. That's not correct, because remember, as soon as there's a bracket, okay, remember from your multiplication laws and that, as soon as there's a bracket, it means everything inside that bracket must be, in this case, since we're dealing with exponents, everything inside that the bracket must be raised to the power outside the bracket. Okay, so this one, xy to the m, is incorrect. You cannot just raise one of the letters from within the bracket. Okay, that's when we're multiplying. When we're dividing, it's exactly the same. Each factor inside that bracket has to be raised to the power outside the bracket. So even though we're dividing, the law stays the same. It's going to be x to the power of n divided by y to the power of n. So both of them, once again, get the power of n. It does not become that. Okay, because that doesn't make any sense. Okay, so to get these two, the x and the y, outside the bracket, we've got to raise each of them to the power of n. Okay. Then when you dealt with rational powers, okay, you would have done this at school already. Remember, a rational number is just an integer over an integer. That's what we call rational numbers. So if we're talking about x to the power m over n, that's my fraction, that's my rational number. So x to the power m over n, we want to convert it, all right, from exponential form to third form, or we want to write it in root form. It's always going to be the x to the power m on the inside, and then your root, which is your denominator, is n. Okay, so your denominator becomes your root, and your numerator is your power. Okay, so your power is really enclosed by your root, which is on the outside there. And remember, it works backwards and forwards. So if I have x to the power m, and we're taking the nth root, so let's take a different example. Say I have a to the power of 3, and I'm taking the root of that, and I want to write that in exponential form. Remember, whenever there's no root, there's no number written inside the root, it's always taken to be the square root. So to write this in exponential form, it's going to be a to the power of 3, which is my numerator, over 2, which is my denominator. So the root becomes the denominator, okay? And then your power here is your numerator. All right. And as I said, you can go backwards and forwards. So if you had a to the 3 over 2, the a to the 3, that dives and goes inside, and then the 2 becomes your root on the outside of the tail. Okay. Something else I'd like to mention, which is not on these 5 or 7 laws or whatever the case was there. How many was that? 6. All right. Something you come across very often, and you're going to need this for your challenge question. Raising a base to a negative exponent. Now guys, as I said to you in the beginning, as soon as you see a negative exponent, it straight away implies division. So a to the negative 1, in order to write that with a positive exponent, it's 1 over a to the positive 1. So what do? We change the position of the base. All right? Look at what's happening. In the first case, it's a to the minus 1 over 1. And then we dive and go under. So that 1 goes to the numerator, and then that a goes to the denominator. Your power then switches from a negative to a positive. All right? But let's look at it with other numbers. Let's have a look at something like x to the power negative 3. All right. If you know the law correctly, right, you won't do that. Okay, that means you're not really understanding how to make your negative power positive. All you're going to do to make your negative powers positive is you're going to change their position. So if we look at this, we've got x to the minus 3 that's in the numerator. I want to change that to a positive exponent, so I make it 1 over x to the positive 3. So from a negative 3, it becomes a positive 3. So again, I'm dividing. It's 1 divided by x to the power of 3. Okay, my negative power was in the numerator. To make it positive, I took it to the denominator. The whole base, the whole power, so the whole thing. We didn't leave the x in the numerator and take the 3 down or do the other crazy things that I have seen being done. Okay, just one more example on that negative power. If you have 2 times b, in fact, let's make this slightly different. Say I have 2 over b, okay? And we are asked to write this 2 over b to the negative 2. Okay, let's make it a little bit more tricky. So we're asked to write this with a positive exponent. Okay, now you look at your base, your b to the negative 2, in your denominator, right? I want to change the entire thing to a positive exponent. So what that means is I need to change its position. It's in the denominator. To make it positive, I take it to the top, so it becomes 2 times b squared. So we go from a negative 2 to a positive 2. I am going on about this quite a bit because it is a place where if you don't understand what you're doing here, it will often give you problems with your simplifying. All right. Make sure you guys understand that. And then the last thing I want to touch on in your summary is anything to the power of naught is 1. Okay, you would have seen that before. Any letter, any variable to the power, any number really, anything to the power of 0 is equal to 1. So in a trick question, we might say, what is that to the power of 0? Well, your answer is just going to be 1. And guys, what I'd like to do is I always like to show students why this is the case, all right? So let's say I have something. So we've got a to the power of naught is 1. Now, where do I get that from? How do I know that a to the power of naught is 1? Remember, in maths, we're not making everything up. It comes from a reasoning and a logic, okay? So a to the power of naught. Let's look at this. If I had a divided by a, right? Now, my rules for dividing of exponents says when you're dividing with the same base, you keep the base, so we keep the a, and we subtract the powers. So I get a to the power 1 minus 1. 1 minus 1 is naught. All right, so I get a to the naught on that side. But on this side, we know just from simple algebra, a divided by a is 1. Therefore, a to the power of naught is 1. So as I was saying to you, it's not something that we just say, you know, this makes your life easier, use it. It does make your life easier if you do know it, but it comes from a reasoning, from a logic. Because really, when you're saying something to the power of naught, it comes from the fact that that expression is divided by itself. So anything divided by itself will give you 1. So that's where the whole reasoning of a to the power of naught is equal to 1 comes from. And it's nice to sometimes have those little backgrounds, you know, those little tidbits of information where you're not going to be examined on it, but it's just nice for understanding. All right. So the two main things here that I want to show you guys. First, you need to remember all of your exponent laws. You need to literally, I say to people, say them like you would your prayers. If you can recite your exponent laws, you will never ever mess up your simplification of exponential expressions. Also, exponents are so important because you guys, you're going to do it later on when you do graphs, and in grade 12 you'll be doing it with logs, and it just comes up over and over and over again. So it's not something that you can just forget about. If it's something you're struggling with, You need to fix the problem now. Okay, remember it's building blocks. We want to get the foundation right. That foundation starts here. Make sure that you understand your exponent laws, and obviously you can test yourself with that. Hey, Abraham.
Yes, you should. Thank you so much, Natasha. And big ups to all the mindsetters that are on the page, such as Moyabo Mahato, Banyana Mohapele, Lungelo Patient, and Mishek Mavung, who says the teacher that is teaching today, whatever she's teaching, it's what I'm going to write on tomorrow, and I like it. So all the best to you, Mishak, and we know that you're going to do well. We trust you. Otherwise, mindsetters, test yourself and get onto the link that I posted on Facebook where you can submit your answers and stand a chance of winning airtime, proudly sponsored by Vodacom. See you after the break. Welcome back, Mindsetters. Now, I told you earlier on that you can also follow us on Twitter. It's at LearnExtra. I see that there are a lot of Mindsetters who are following us, but I must urge you that as you have taken those test yourself questions, you have up until 10 o'clock in the midnight today to submit your questions and stand a chance of winning your airtime, proudly brought to you by Vodacom. And remember, Mindsetters, the link is posted already on Facebook where you can submit your answers. It's simple, Natasha. You just test yourself and then submit the answers, and who knows?
Yeah, no.
Tomorrow your name might be called.
So hopefully you guys are understanding everything you need to from the lesson, and you're finding those tests yourselves really, really easy. Abraham, do we have any answers yet?
I'm seeing that the mindset, maybe they are still like looking at the questions, and it's simultaneous. It's like simultaneous kind of question. It's simple questions, simultaneous, and like you choose multiple choice. So I think it should, at the same time, it shouldn't be just in a pick. You must practice and you must do those questions, because a lot of mindsetters, I think they just see it's multiple choice and they go like, okay, it's A.
Yeah, so they'll enter 4 times for each question.
Make sure that you do it the right way. Otherwise, let's continue.
All right, guys. So hopefully you won't be going eeny, meeny, miny, mo. You'll understand all of your exponent laws, because you need those exponent laws not just for the test yourself to win your prize, but you also need it for the rest of grade 10, 11, and 12. Okay, so I'm going to go into the improve your skills questions, and I've taken different types of questions that you guys can get in a test or exam situation. So first we're going to start off by looking at multiplication of exponents, so simplify while we are multiplying exponents, and then we're going to look at what happens when you're adding the exponents, and then later on we'll have a look at equations. All right. So in question 1, we're asked to simplify that exponential expression. All right. Now, guys, if you have a look at the question, we've got 20 to the power x plus 1 times 4 to the x divided by 16 to the x minus 1 times 5 to the x. Whenever you deal with any exponential expression, you need to simplify down to prime bases. Okay, prime bases. Now, what does that mean? Hopefully, that rings a bell. Prime. You've heard that before. Where did you hear it? Long ago when you learned about prime numbers. It's the same thing we're talking about. So, a prime base is just a prime number, really. So, it just means that your base of your exponents is going to be a prime number. So it is key before you try to simplify any exponential expression to get it down to prime bases. So here we're talking about things like 2, 3, 5, 7, those numbers that only have 2 factors, 1 and then themselves. All right. So we want to firstly get everything down to prime bases before we start tackling this question. Okay. So let's have a look at the 20, right? So 20 we can rewrite. We know that it's 4 times 5, and I'm just doing it as an aside. But that's not going to be good enough, guys, because 4 is not a prime number. Okay? But we know from exponents that we can rewrite 4 as 2 squared. Right? It's 2 times 2. So we can rewrite 4 as 2 squared. And now when we look at this, 2 squared times 5, 2 is a prime number, 5 is a prime number, so that means my whole base is now a prime base. So I'm going to rewrite the 20 to the power x plus 1 as 2 squared times 5. So you see I've rewritten the 20 2 squared is 4, 4 times 5 is 20. I haven't changed the value. And that's all raised to the power of x plus 1. Okay? Then we've got times 4 to the power of x. We do the same thing. 4 we can rewrite as 2 squared. We can simplify it into exponential form as 2 squared. And then that's raised to the power of x. And it is quite important, guys, well, it's actually very important that you don't lose your brackets, because especially when you're raising powers to powers, you may forget to give it to the other number inside the brackets, okay? And in the denominator, we've got 16 to the power x minus 1. 16 we can rewrite as 2 to the power of 4. Now, guys, just at that point, what you need to remember is certain exponents and bases in that, you know, they come up over and over again. So the ones that you should just know in your head without having to reach for your calculator: 2 squared prime factorized will give me 4 prime factorized will give me 2 squared. 2 cubed, using my exponents, is 8. All right, 2 to the 4 is 16. And then I would say go as far as 2 to the 5. Learn these ones off by heart, because these come up over and over again. So you don't want to always be looking for what is 16 as a prime base, and then you're going to go 8 times 2, and then you're going to break the 8 up. It's going to take way too long. Okay, so learn those ones off by heart. So 2 squared is 4, 8 is 2 cubed, 16 is 2 to the 4, and 32 is 2 to the 5. You must be able to write those with their exponents without even thinking about it. Okay, so that's 16, 2 to the 4 to the power x minus 1. That goes outside my bracket. And then that's times by 5 to the x. 5 is already in its prime form, so we don't have to do anything more to it. All right. Now, because we're dealing with multiplication of exponents, what is the next step? Well, firstly, we need to get rid of these brackets. And then once we've gotten rid of the brackets, we need to put the like bases together. Okay, similar to adding like terms. You want all the like things together. All right. To get the 2 squared out of the brackets, remember the rule. We raise a power to a power, so it means we multiply the powers. So it's going to become 2 to the power of 2. And what I sometimes do, especially when we're starting off in the beginning, is we write this in brackets. So you will not forget that the 1 also needs to be multiplied by the power of 2. Okay, so we raise a power to a power, we multiply the exponents, and then it's 5 to the 1 times x plus 1. That's going to stay exactly the same. All right? And then I've got times 2 to the power of 2, all raised to the power of x. What do you do there? Just raise your power to a power, so that means we're going to multiply the 2 and the x, so I get 2 to the power 2x. Okay, and then at the bottom, in the denominator, we have 2 to the power of 4 raised to the x minus 1. Raising a power to a power, we multiply the powers, so it's going to be 4, and again, when it's 2 terms, rather keep it in a bracket, so you remember that each element has to be multiplied by your exponent, and then we just bring down the 5 to the x. All right. We can then simplify that a little bit further. So we're going to end up with, timesing the 2 into the bracket, we'll get 2 to the power 2x plus 2 times 5 to the power x plus 1 times 2 to the power 2x. And I'm putting in extra steps because I want to go through it in detail, especially for you guys who may still be a little bit confused with this section. At the bottom, I'm going to get 2 to the power 4x by distributing the 4 into the bracket, minus 4 times 5 to the power of x. Okay. Now, guys, once you have everything with similar bases, right? So we've only got the base of 2 and we've only got the base of 5. Now what we need to do is we need to put the similar things together. So if I look here, I've got 2, I've got 2, I've got 2. We're going to use our laws of exponents and put that together. And then I've got 5 and I've got 5. Again, using our laws of exponents, we're going to put that together. So, in the numerator, I've got 2. Remember, when we multiply with the same bases, we add the powers. So I keep the base 2 and I add the powers. So I get 2 to the 2x plus 2 plus that 2x. All right, so I've taken care of those 2. Now look at the bottom here. We've still got 2 to the power 4x minus 4. When you divide with the same base, you subtract the powers. So we're going to subtract the power of 4x minus 4. Okay, so what have I done? I've grouped all of these 2's together. Do you see? Just 1, 2. We've just got one base and we've put all the powers together, just simply using our laws for exponents. And then that's going to be times by, with our 5's, we've got 5 to the power x plus 1. And we're dividing with the same base, so we're going to subtract the x from the denominator. Okay. Now we can add our like terms. So I'm going to get 2 to the power 2x plus 2x is 4x. 4x minus 4x is going to cancel away. Then I've got 2 minus times a minus is a plus. So that's going to become plus 4. 2 plus 4 is going to give me 2 to the power of 6. Times by simplifying the powers of the 5. X minus x cancels. And I'm just left with 5 to the power of 1. Guys, you can leave it at that step. There's no need to go further and say, okay, 2 to the power of 6 is now 64 or whatever it is. Just leave it at that point there, simplified in exponential form. All right, so to go over what do you need to do when you're multiplying with the same base, first thing, break down to your prime bases and then simplify. So once you've got prime bases, then you can attempt to simplify by putting the powers together using your laws of exponents. Okay. In the next example, we're going to look at what happens when we ask to simplify an exponential expression. But in this case, we no longer have multiplication signs. We now have plus signs. Now, you'll remember from your first lesson that we did on simplifying algebraic expressions, the only way to go about simplifying an expression where you've got terms that are added together, the only way you did it before was by taking out a highest common factor. And in exponential expressions, it's exactly the same thing. We need to factorize this in order to simplify it. All right. So same rule applies. We first need to work out our prime bases. So this is going to be equal to. We look at the first term. We've got 2 to the power x plus 1. We can leave that alone. But 4 to the power of x. 4 is not a prime number, so I need to break that down. So it's going to become 2 squared, okay, in exponential form, raised to the power of x, all over 2 to the x minus 2 to the x minus 1. All right? So that's what that becomes. Now, simplifying that, I've got 2 to the x plus 1 plus 2 to the power 2x all over 2 to the x minus 2 to the x minus 1. And guys, just like I showed you in the other lesson when we were dealing with algebraic expressions, you cannot cancel across terms. You also can't cancel across here. So you cannot take this. So say we had something like that. Cannot just do that. Okay, remember I showed you last week, if you cancel across like that, you're actually changing the answer of this entire expression. Okay, you cannot, not allowed to do it. Not allowed to cancel across terms. Okay, the only way we can simplify this is by factorizing. Okay, now remember, in order to get to 2 to the x plus 1, right, if I had 2 to the x times 2 to the 1, it means that originally my bases were being multiplied. Because 2 to the x times 2 to the 1, I keep the base and I add the powers. So keep the 2, add your powers, you get 2 to the power x plus 1. So it goes backwards and forwards, right? I'm just showing you this as a way of making it slightly easier to factorize an exponential expression. So 2 to the x plus 1 I can rewrite as 2 to the x times 2 to the 1. I can break it down because in order to get to that answer, 2 to the power x plus 1, is basically just the reverse process. Okay. Why do I want to do that? I want to then show you guys that really what you're doing now when we're taking out a common factor is we're breaking this down and then pulling out the term exactly like you did with finding a highest common factor in algebraic expressions. We're just pulling out the factor that's common to all of the terms, right? And then at the bottom I've got 2 to the x minus 2 to the x times 2 to the minus 1. Okay, so this is a step that you don't really have to show. I'm just putting it in so that you guys understand how I'm taking out my common factor. And in fact, 2 to the power of 2x, we can also, that could have been written as 2 to the x times 2 to the x, right? So that would have given me keep the base, add the powers. So 2 to the power of 2x can also be written as 2 to the x times 2 to the x. So essentially what I've got here in this the second term, I can write as 2 to the x times 2 to the x. All right. Again, it's just for clarity, just showing you guys how come now, if I look at this, I can see that there's a common factor, exactly as you did in algebraic expressions. There's a common factor of 2 to the power of x in both the numerator and the denominator. So we don't just cancel it out, we pull it out as a common factor. So in other words, we divide through by the 2 to the x. Okay, so if you're dividing by 2 to the x, you're going to be left with 2 to the 1 in your brackets, plus, we're taking one of them away out as a common factor, so I'm left with another 2 to the x. That's all over. We take our 2 to the x in the denominator, and I'll be left with 1 minus 2 to the negative 1. All right? Now that we have our common factor out of the brackets, we can now cancel the 2 to the x's out, and we'll be left with 2 plus 2 to the power x all over 1 minus 2 to the minus 1. Now guys, this little thing here at the bottom is not completely simplified. We can go one step further, and I'm going to take that by itself and show you what we can do there. I've got 1 minus, remember 2 to the minus 1 we can rewrite as 1 over 2, because 2 to the minus 1, I want to make that a positive power. I rewrite it. It was in the numerator, I take it to the denominator. My power changes from a negative 1 to a positive 1. Okay, 1 minus a half is just a half. So this expression then becomes 2 plus 2 to the power x over a half. And then remember, when you're dividing by a fraction, you tips and times, invert and multiply. So this is going to become 2 times 2 plus 2 to the x. All right. Can you go further there? No, you can leave it at that point. You don't need to go any further and multiply the 2 into the bracket. But that's really where it stops. You can't simplify much more than that. You're just going to be going backwards and forwards with the same thing. All right, I think before we start the exponential equations, we should perhaps take a break.
Yes, we should, Natasha. And I must say this, it seems like everyone is writing this Wednesday or tomorrow. So it's a good show that we're helping the mindsetters.
Correct.
Hopefully they're up and ready and learning so much, as they say. But otherwise, remember, you can still take the test yourself questions before 10 p.m. tonight and stand a chance of winning yourself an awesome airtime voucher proudly sponsored by Vodacom. So the link is on the Facebook page at facebook.com/learnextra. Get on it, because we want to get all your answers. And hopefully they'll be right. Otherwise, see you after the break. Welcome back, awesome mindsetters. Now, I see that there are a lot of answers in terms of the challenge question. We'll see the right answer because Natasha is going to be telling us more, treating that question. But otherwise, keep your questions coming. If you have any questions, if you're struggling anywhere, we know that some of you are writing tomorrow or rather this week. Keep your questions coming. We are on facebook.com/learnextra. Over to you, Natasha.
All right, guys, so we want to get into the challenge question first because I understand quite a few have put answers up. But Abraham, I think there was also a question about the previous denominator,
Yes.
if I'm not mistaken.
It's from Tepiso Tsoteti. He says the teacher made a mistake on the denominator regarding the sign of 1 in the bracket.
I don't think so. I'm not seeing a mistake. We took out in the denominator a common factor of 2 to the x, and we were left with 1 minus 2 to the negative 1. And we changed 2 to the negative 1 to a half. We got 1 minus a half, which is a half, and then we tips and times. I'm not seeing the mistake there. Okay, so maybe, what was his name again?
Tepiso.
Tepiso. Tepiso, just go back and have a look and double check there. There was definitely no mistake in the bottom, in the denominator. I always say bottom, that sounds so wrong. There was a mistake in the there was no mistake in the denominator of that question. All right, so let's get straight into the challenge question. I see there's so many answers, and I'm dying to see if you guys are right. So let's get to it, and hopefully you all use that information that I gave you, x to the minus 1, 1 over x. When we see a negative power, we need to think division. Okay, so let's go through this. X to the minus 1. Firstly, we're going to simplify this. We don't want these negative powers because it means we actually can go nowhere there. So we want to get rid of those negative powers, right? I can rewrite x to the power of negative 1 as 1 over x minus y to the power of negative 1 is 1 over y. Okay, and then that's all divided by x to the minus 1 times y. Now this is where, guys, you need to understand your concept. The y is going to stay in the numerator of this division, and the x to the negative 1, which is going to become our positive exponent, we want to change that from negative 1 to positive 1, is going to move to the denominator. Okay, minus, same thing here. Only the y has the negative power, so only the y must move. The x must stay exactly where it is, so it becomes x over y. All right. Hopefully you guys got to that point because that's already really good. Okay, that's the tricky part, getting rid of all these negative powers. Once we've gotten rid of that, this is just a complex fraction that you guys have simplified before. Okay, but the exponents are now basically gone. There's no exponents left. So the only exponential simplification really was changing from negative powers to positive powers. That's it. All right. So I've got 1 over x minus 1 over y divided by y over x minus x over y. How do we simplify this? Well, we need to find, if we're dealing with fractions and we're dealing with addition or subtraction, we need to find a common denominator. So my LCD in this part of the question, and I'm going to split it up into 2 pieces so you guys can follow easily. 1 over x minus 1 over y, my LCD there is xy, right? And I'm going to get, by finding an LCD, I'm going to get y minus x all over xy. So I've times 1 by y, I get the y, and then 1 times x, I get x, and my common denominator there is xy. So now everything is over the same denominator. Okay? That then is divided by, and now I'm going to do this little bottom piece here, the little denominator fraction that we were dealing with. So it's all divided by, your LCD in the denominator is xy once again. Okay? We've gone over this before. You want to find an LCD, so we're going to times each element in the numerator by what it doesn't have to get it to xy. So I'm going to times y by y, so I get y squared, minus, I'm going to times x by x, so I get x squared. Okay. As I said, guys, once you get here, there's really not many exponents left. Now we've got the squares in, but that's it. It's all just simplifying algebraic fractions. So I've got y minus x all over xy. When we divide by a fraction, we tips and times, so it's going to become times xy over y squared minus x squared. And as I say over and over again, maths is building blocks. Look, this is your factorizing that we've done a while back that you already know, difference of 2 squares. It comes back over and over again, the same concepts. Okay, xy xy. We've got xy in the numerator, we've got xy in the denominator. We're not cancelling across terms. That's correct. We can cancel those two off. Then we're left with y minus x all over, because remember there's a 1 there, so y minus x times 1 is just going to give me y minus x, and then 1 times y squared minus x squared is just y squared minus x squared. Alright, you can go one step further because we can factorize the denominator. Factorize it using difference of squares, so I'm going to get y minus x times y plus x. Okay, now that it's factorized, the y minus x in the numerator cancels with the y minus x in the denominator, and we're left with 1 over y plus x. Do we have any takers, Abraham? Did anyone get that?
Yes, a lot of them.
Well done.
A lot of them.
Well done. That's brilliant. Okay, it means you understand all the work we've done previously, which is fantastic. Great.
That's great. That's great.
All right, guys. So we're going to move on to our exponential equations, unless, Abraham, there's any other questions.
There's one question from Banyana Mukhabane. Do you need to always find the prime base?
Yes, okay, this is what we discussed in the beginning before the break when we started looking at the Improve Your Skills questions. Whenever you're dealing with multiplication or division of exponential expressions, or if you're dealing with addition and subtraction of exponential expressions, you always have to have prime bases. So you need to simplify. So for example, if you have 25, you need to make it 5 squared. So you have to work with prime bases each and every time. Absolutely. All right. Okay, guys, so let's get back into our question 3, which is exponential equations. Now, again, you get different types of exponential equations. What I'm going to look at is the type of exponential equations where you've got to make the bases the same in order to simplify. But you guys will also eventually do the types of exponential equations where your base is actually the x and you've got to get rid of the power. So we're not looking at those types right now. We're looking at the types where your x is actually in the power and you've got to make your bases the same. Okay, so this is now question 3a, and we asked to solve 2 to the power x minus 3 is equal to a quarter. So we've got 2 to the x minus 3 is equal to a quarter. So the same rule, in fact, what the viewer was just asking is, do we always have to change to prime bases? Yes, absolutely. Every time you deal with exponents. So in order to solve an exponential equation, we need to have the bases the same. Because guys, if you think about it, say I have 2 cubed is equal to 2 to the what? Obviously, that power there, that x, that unknown, has to be 3, because 2 cubed is 8. So if I want these two things to be equal, the power on the other side also has to be 3, right? Now, the examples you're going to be dealing with are not as simplistic as this, okay? But the concept is the same. In order for your two expressions to be exactly the same on either side, they need to have eventually the same power. Okay, so that's what we're dealing with. Your bases are the same, so in order for these two things to be the same, your powers have to be the same. Okay, so let's deal with ones that are slightly more complicated than that. So 2 to the power x minus 3, I will leave as 2 to the power x minus 3. This is where we now say you have to always deal with prime bases. For a quarter, in the way it stands in this expression, there's nothing we can really do to this equation, right? So what I'm going to do is I can change 4 to the prime base of 2, and 4 we know is 2 squared. Okay, so the objection here is to try and get the bases the same on each side of the equality sign so that you can equate the powers, all right? So 1 over 2 squared, my base is not yet 2. I've got to rewrite that 1 over 2 squared. And if I rewrite that, it's going to be 2 to the power of negative 2. Okay, so all I'm doing is simply rewriting that with just a base of 2. All right. So now I end up with 2 to the x minus 3 is equal to 2 to the negative 2. because these bases are identical, we can say, well, for this to be equal to that, left-hand side to be equal to right-hand side, because remember with your equations, even the linear ones you did last year, the left-hand side must always equal the right-hand side. So in order for that to happen, right, because obviously the bases are exactly the same, the only way it's going to happen is if the powers are equal to each other. Okay, so therefore we will get x is equal to, take the 3 over to the right hand side, 3 minus 2 is 1, so therefore x is equal to 1. And guys, what you should always do is check if it makes sense, because if you took the 1 and you put it back into the x there, you're going to get 1 minus 3. 1 minus 3 is 2 to the minus 2, so it's exactly the same as what's on the right hand side. And that's the beauty of equations, is that you can always check really if your answer is correct by simply substituting the number, your answer, back in and seeing if it balances out. Okay, we always, if you're dealing with equalities, there's always got to be equality on both sides, left hand side and the right hand side. Okay. Alright, so there we had to make the bases the same, equate the powers, and then solve for x. Now, with the next example I'm going to do, number 3b, it is slightly more tricky. Some of you may have seen it. Some of you may not have seen it. But I would like you guys to follow along with the concept, because regardless of whether you have seen it now or you haven't seen it, you will eventually need to know this for the end of the year, for grade 11, and so on. Okay, so here, this one is looking slightly different. We've got 3 to the power, well, a lot different. 3 to the power 2x minus 2 times 3 to the x plus 1 minus 27. And I'm going to have to rewrite that at the bottom here so I can get some space. Okay, and this is b. So we had 3 to the power of 2x minus 2 times 3 to the x plus 1. And then we had minus 27 as the constant term. Okay, and I want to try and get through this, and hopefully you guys can follow this, even if we don't get to the very last one. Okay, so here you can't really make your bases the same because you've got more than one term. Okay, so the bases of the same will work if you've got one term is equal to one term. Here we've got 3 terms is equal to 0. So we can't really do that. So what we're going to do, guys, is I'm going to rewrite this firstly so that it looks a little bit more like a quadratic expression. Remember quadratics? Quadratics, your highest power is 1. Okay, and then we've got 3 to the x times 3 to the 1 minus 27. So all I've simply done here is I've split up 3 to the power of x plus 1 into 3 to the power of x times 3 to the 1, just to make it simpler to introduce this concept. Okay, now what we're going to do is we're going to introduce something, because if you have a look here, guys, we've got a common factor in the first 2 terms of 3 to the x times 3 to the x. Okay, and we know that this exponent here is exactly a half of that one. Now, you guys would have seen when you did quadratic expressions, if I have k squared minus k minus 2, for example, we can do something with that. We can factorize that. So that's the concept I need in order to simplify this exponential equation. So what I'm going to say, and for those of you who are seeing this for the first time, well, it's good, because now you know something that everyone else doesn't know. We're going to say let 3 to the x equal k. All right. Now, the reason I'm introducing this other variable is just to make it look more like something you guys would have seen before. So if I say, let's replace the 3 to the x with the k, that means wherever there's a 3 to the x, I'm going to replace or put in a k. So my first term is going to become k squared minus 2 times 3 here is 6, so it's going to become minus 6k minus 27 is equal to 0. Now, when it's in this form, you guys will learn how to do quadratic equations if you haven't already. I can now just simply factorize that. I've got a nice, neat quadratic expression that I can factorize. And my factors are going to be k and k. Factors of 27, 9, and 3. We need a minus 9 and a plus 3. So therefore, I'm going to get k is equal to 9, or k is equal to negative 3. How did I get that? That's from your quadratic equation where you let each bracket equal to 0. Guys, we have run out of time, but I want to very, very quickly give you the answer. Okay? So you let each bracket equal to 0. Remember, k was 3 to the power of x. So in the first case, 3 to the x is equal to 3 squared, and therefore x is equal to 2. In the second case, you don't have the same bases, so therefore you can't solve. So we went through that really quickly, but hopefully we'll have time later on in the year to go over it again, Abram.
Thank you so much, Natasha. You know, when you're learning, time always flies. But otherwise, thank you for tuning in. Grade 10s. Hopefully, even next week, you are going to tune in for your maths. Keep your questions, your answers coming on the link that is posted on Facebook. But otherwise, if you're still struggling, go to the help desk at mindset.co.za. But from me and Natasha and the rest of the team, we just want to leave you with peace.